All right, everyone. Hello again. I thought we would take a look at another example. So you'll remember in the last video, I said we'll do another example of adding fractions of different denominators. So we're going to do that. We're going to do another example, adding fractions, different denominators. It's kind of difficult for some people. So we like to do multiple examples. Whenever we're doing math, learning new concepts, more than one example is the way to go. It's not enough to see it be done. We have to do it with repetition. Just like you would at a sports practice, shooting 3 pointers in basketball. Maybe you don't just shoot it once and sink it, and you're like, okay, I'm good. You got to do it again and again. Same idea here. And I also said I'd explain why the method for adding fractions with different denominators works and why it's even mathematically valid. So we'll do both. I like to keep these videos about 3 minutes, so I already took up a minute. So let's do this. Nice and quick. If you want to see a more slow version, take a look at the last video. What fractions can I come up with? I will take a look at 21. Oh, wow, look at that. I don't even have my pen ready to go. There we go. Let's take a look at... Sorry, I'm tired. Let's take a look at... We have 17 over 21. We'll add... I'm just making these up off the top of my head. 5 over 7. Okay. Well, the first thing we need to do is make the denominators the same. That's the bottom part of each fraction. And if you'll remember, 7 times 3 equals 21. So we can multiply the second fraction, 5 over 7, by 3 over 3. Because this gives us 21 on the bottom. So 17 over 21 plus the bottom is 7 times 3 is 21. Top part, 5 times 3 is 15. And now we just add. We leave the denominator the same. So the final answer is going to be over 21. And we have 17 plus 15. And I'm bad at mental math, but I believe that's 32 over 21. And that's our answer. So, and I think this is fully reduced. I don't think you can divide. They don't have any common divisors, 32 and 21. Let me know if you think I'm wrong. I don't think I am, though. So that's the answer. So the idea is always make the denominator the same. Okay. 20 seconds. Why does this work? I think it'll be overtime. Anyways. Well, what is 3 over 3? So let's break this example down. So why does this step? Why are we even allowed to do this? It's not just random, right? In math, when we do things, there's always a reason. We don't just make things up. I know it seems like it sometimes. That's for sure. We're not magicians, though. There's always an explanation. So, 17 over 21 plus 5 over 7 times 3 over 3. Well, the reason this works is we're not actually changing what 17 over 21 is. Let me break it down for you guys this way. So we have 17 over 21 plus 5 over 7, right? Well, we know that when we multiply a number by 1, it doesn't change. So if you multiply 3 times 1, it still equals 3. 100 times 1 still equals 100, and on, right? So when you multiply 5 over 7 by 1, it still equals 5 over 7. And we'll notice that 3 over 3 equals 1. Any number divided by the same number, it equals 1. So when we're multiplying 5 over 7 times 3 over 3, we're not actually changing anything, because in reality, we haven't even changed the question. So it's 5 over 7 times 1, which is the same thing. So we're totally allowed to do that. That's the idea, right? In equations, when you have an equal sign, it has to be equal. Like, these two things have to equal each other. But 3 over 3 is just 1. So that's why it works. I hope that makes sense. Went a little longer than I normally do. Let me know if you want me to do more examples, any other explanations. If you like this video format, let me know. Or if you don't, hopefully you do. Either way, thanks for watching.